Hello and welcome to my video, lesson 3.4, probability with set theory. So to begin with, we're going to be talking about Venn diagrams. So Venn diagrams must add up to 100% or to 1 if you're using decimals. So let's just figure out what that means precisely. Okay, so all of the different parts of the Venn diagram, just like in set theory when we had a total of let's say there were 300 kids surveyed, some said this, some said that, and some chose to not respond. There are multiple categories here. So here is one of the numbers. So let's say this is 30%. Let's say this is 42%. Let's say they have a common. Let's say they have a common 10%. No, let's make it 13%. And so now, if you add up all three of those, it still doesn't get us to 100. So we have to go 100 minus those to find our last value, which is, so 85, so 15. So there's a 15 outside of the two sets. So just be aware of that extra number and be aware that all of those numbers have to add up together. Now, if you don't remember set theory, just keep in mind that both of these numbers together are what give us this first part, whatever this is, event A. Maybe I'll just label it A. And these two numbers, if you add those together, give us event B. So just be aware of that. That 13 is shared. That's what the Venn diagram is showing. Okay, so let's take a look here. Mutually exclusive events are events that cannot occur at the same time. Which of the following are exclusive, which are non-exclusive? So exclusive events, maybe just pause the video and try it out right now based off that definition. So exclusive events are ones that cannot occur at the same time. Now, if we read this, only psychopaths would chew gum and eat food at the same time. I consider these exclusive. You don't chew gum and eat food at the same time. Only psychopaths do that. So anyways, so that's that. Question 2 or option 2, situation 2, watching The Matrix tonight, watching Spider-Man tonight. Again, exclusive. You can't watch two things at the same time. You can't be at two things at the same time. You can't exist in two places at the same time. If it just said that you have watched The Matrix or watched Spider-Man, those would not be exclusive because in the past, at some point, you could have watched Matrix and Spider-Man could be at a different time. That'd be okay. But because it has this time limit, that does make it exclusive. Drawing a heart and a spade at the same time, they are suits. So those are also exclusive. They are different. Okay? Whereas a heart and a king, well, you could draw a king of hearts. That would be perfectly fine. So this is non-exclusive because you can do both at the same time. Okay, so just keep that in mind. Now let's take a look at this question. Let's see how much room we have. Let's actually make this a little bit more. Yeah. Okay. And actually, let's keep that. Okay, a survey of St. Joseph High School students shows that 15% have their driver's license. 15% have their driver's license. 50% take public transit to get to school and back. So determine the probability that a randomly selected student has a driver's license and doesn't take public transit. So what we really want to do here is actually draw ourselves a Venn diagram. It's probably the easiest way to go about this. So draw the Venn diagram. Now, there are two situations. There is driver's license, DL, and there is public transit, so PT. Now, could you have a driver's license and take public transit? Absolutely. Just because you have a driver's license doesn't mean you have to take you have to drive your car. I had my driver's license in high school, but I want to say never. Maybe there was one time, but I want to say never drove the car to school because I didn't have a car. I would borrow my parents, so they didn't lend it to me. Anyways, no hard feelings on that one. Just kidding. Seriously, no hard feelings. Okay, so driver's license, in fact, I think it was good for me. Driver's license is 15%, public transit is 50%. Oh, you know what we forgot here? We forgot to add a neither category. So anyways, 30% said that they don't have a driver's license and don't take public transit. So that is a key and, because this lets us know that 30% are in the neither category. Okay, they don't have it and they don't take public transit. So now what we can do is we can kind of backfill the rest of it. If you remember our equation from probability, it's the union of A and B equals A plus B minus the intersection of A and B. Okay, let's see if we can just get a little bit more room to work with. There you go, minus the intersection. Okay, so this is the union of A and B. So this is everything that A and B can be together. Now, keep in mind that we'd have 100 here, except that we know that there's 30% that aren't there. So that's this. So then we also have 60 plus 15 minus the intersection. So that gives us 70 here. This gives us 75 minus intersection. Now if we move the intersection over and move the 70 over, now we know that the intersection is 5%. Okay, so intersection is 5%. So now we can go through and figure out each part. So driver's license is 15 minus 5, so 10%. Okay, public transit is 60 minus 5, so 55%. Excuse me. So determine the probability that a randomly selected student takes public transit. Let's do A, which is randomly selected student has a driver's license and doesn't take public transit. Okay, that's 10%. You can see that right in our Venn diagram. That's the beautiful thing about a Venn diagram. And then secondly, determine the probability that a randomly selected student takes public transit while having a driver's license. So that's the intersection. So that is the 5%. All right, I hope this video helps you understand probability in set theory a little bit better. Good luck.